Hello and welcome to today's Rancher Online Meetup. Today we're going to be talking about storage. I'm just going to give it 2 minutes while we wait for a couple more people to pop on the line, and then we'll kick off. Okay, let's get started. So, hello everyone, my name is Chris Irwin. I'm the Director of Field Engineering at Rancher Labs, and I'm standing in for Sheng Williams, who's unable to take today. So I actually did the meetup last month where we talked about CI/CD, and today we're going on to storage. Now, in the sort of the area that I work in, we're regularly meeting with a lot of customers, and storage is probably one of the top 2 topics that we talk about. So I'm quite excited to see this because it's another area that I can refer people to for looking at how they do this thing. So I'm joined on the call by 2 of my colleagues. So I've got Jason from Brackel. Jason, do you want to say hi?
Sure thing. How y'all doing?
And Sheng Yang. Say hi, Sheng.
Hi, I'm Sheng. I'm from the Rancher Labs. I'm doing on the Longhorn project, which is purely Kubernetes-based storage thing. And then you'll see more update later.
Fantastic. Okay, so first things first, and Shannon always goes through these slides, so I'm just going to go through them quickly. And so the first thing is, this is a meetup, not a webinar. So there's a few rules for our meetup. We won't be done on time. So the time is scheduled for an hour and it regularly goes to 2 hours. We'll finish when we finish, and we won't leave until all questions have been answered. Questions are welcome, so please use your chat in the WebEx and raise any questions. So anything on Docker, Kubernetes, anything related to storage as well. There are no bad questions. We just want to help people get started with containers and get you up and running. We're going to do a lot of demos. So these webinars, these meetups are always sort of very demo heavy. We like to show a lot of demos, and please do bear with us. Sometimes these things break, sometimes cloud providers disappear, but we've usually got some sort of backup and we can talk around things. So please do bear with us if things seem to be going a bit wrong. Okay, so this meetup is being recorded. As we do with all of our meetups, they're going to be available on the YouTube channel probably tomorrow, if not later this evening. We've got about 4,000 people registered for this meetup, so there's expected to be a lot of questions going through, and please do bear with us. So what I'll do is, if there's specific storage questions, I will wait and ask them to the relevant presenter, and any that sort of are general ones, I'll reply probably in the general window and give you an update on that. Okay, so we are on Twitter. If you use hashtag Rancher Meetup, please do send us your tweets. We love to see photos of people, what they're doing while they're watching the webinar. You may be having breakfast, lunch, or tea. Please do send us a picture. We love to see that people are doing this and sort of participating. So the agenda, what we're going to go through today, so we've got understanding storage in Kubernetes, and Jason's going to pick that up, and then he's going to demo storage principles with Rancher 2.0. And then we've got Sheng talking about container native storage options for Kubernetes and giving us a demo of one of our products, Rancher Longhorn, which is in our beta product, but yeah, Sheng's going to give us an overview of the latest release that we've got, and then I'll pick up any remaining questions and answers towards the end of the seminar. Okay. So for those of you who aren't familiar with Rancher, we're a software company and we basically build open source software. We have 3 products. So we've got Rancher, we've got Rancher OS, and we've got Longhorn. So primarily, we talk about Rancher, but obviously in this meetup, we're going to be talking a fair amount about Longhorn as well. So Rancher is the most popular of the three that we've got, and it's our container management platform. It's free to use. It's very easy to use. It can be used hosted, on-prem, and it solves problems basically that people are facing when they're trying to run containers in production. So things like linking to an enterprise directory for authentication. We sort of tie in some logging and monitoring and storage and access controls. And basically, we monetize this by sort of selling support contracts. So people who need to go into support, support a configuration of Kubernetes and run it in production, then that's what we're here for. But we sort of value our open source users, and they give us a lot of valuable feedback and help shape our roadmap. So we love everyone who uses Rancher. We're completely platform agnostic, so managing Kubernetes and containers wherever, it doesn't matter. You can run sort of any cloud provider. As we can see in the slide, you can run it on sort of VMware on-prem. You can run it on Microsoft Azure, either using machine instances or using AKS. Same with EKS and a number of other cloud-native sort of Kubernetes platforms. We sort of will manage all of the things related to Kubernetes, so we can push down our RBAC and give you the centralized authentication regardless of where this stuff's running. And basically, we're going to show you how to sort of utilize storage with the sort of Kubernetes and containers that you stand up today. So we look at it from two sort of aspects. We look at it from a developer role and also from a sort of an ops role. So Rancher's been made to appeal to both, and we've got functions in there explicitly for both. And we're just trying to make adoption of Kubernetes and containers easy. So we have all of these things, like I said, the unified cluster management and sort of a bunch of wraparound information sort of you can see on the slide. These slides are fairly familiar, and I'm not going to go into them in any more detail. What I'm going to do is I'm going to move forward, and we're going to get to find out about understanding storage options for Kubernetes and Rancher 2.0. So I'm going to hand over to Jason. Are you ready to share your screen?
I am ready.
I shall hand over control, and you should be good to go.
All right, can you see my screen okay?
I can.
All right, good. So I'm going to move this over so I can see it.
Oh, sorry to interrupt. There are questions regarding somebody cannot hear the voice or get very poor quality of core. So can someone hear us and confirm that everything works for you?
Yeah, we've got a confirmation now.
Okay.
Yeah, sounds good.
Okay.
All right, thank you.
Good. All right, so I'll get started. Welcome to Understanding Storage in Kubernetes. Today we're going to talk about storage APIs in Kubernetes, specifically volumes, different various volume types, file-based volumes, as well as persistent volumes, dynamically provisioned and statically provisioned volumes, and then how to use them, and then other various storage options between cloud, on-premises, and CSI. So there are a number of storage APIs in Kubernetes. If you were to go to the Kubernetes API reference documents, you see they break them up into two areas. One is configuration-based storage APIs, and one is storage-based storage APIs. The configuration-based being config map and secret. They're both key value pairs that can be mounted as files within the Kubernetes containers. Config map and secret. The only difference is that config map is unencrypted and the secret is encrypted. And there have a number of different storage APIs, and we'll walk through some of those as we go today. So the Kubernetes Volume API. This isn't like a volume within your file system. This is a specific API within Kubernetes. It just happens to be called volume, and it solves two basic problems. One is death of the container, and file sharing among containers. So within the Kubernetes pod, if the containers die, the volumes they're working with under a normal Docker situation, those volumes go away. They're no longer the container restarts, but the file you may want persisted is then gone. So this solves the container death problem. Containers can die, spin back up, and then attach the two volumes they had before. And then file sharing. The pod is essentially running as local hosts. Those two containers can see each other's shared files in the volume, and it has a lifetime of the pod that encloses it. So once the pod is recycled, then the volumes attached to it are then gone. There are a number of volume types. I'm not going to name them all here. I just listed them out. These are all built into. Most of these are built into Kubernetes. There's also the Flex volume, and there's CSI plugins. But these are the ones that are basically built into Kubernetes. Some of them are cloud provider based, like your Azure Disk, your AWS Elastic Block Store. Some of them are meant to be local, things like your vSphere volume, for example. They all have different features, but to give an idea, these are your different volume types. When you notice that persistent volume claim, the other Kubernetes API object over there on the right, so even the persistent volume claim API is considered a volume type in this case. So the volume types can vary. They can be ephemeral, they can be mounted host files and directories, they can be external storage or API objects like the persistent volume claim. The life of the underlying files varies by the volume type, so go read the docs. If you go out to the Kubernetes documentation, so I'll share it right here, so I keep a copy of it out here. If you go to the Kubernetes documentation, under concepts, and then down to storage and volume, and then types of volumes. And then every item here has a specific configuration and life cycle that's described here on the documentation. So by all means, don't be a lazy engineer, go read the docs. Then you have two types of volumes, essentially, in-tree volumes and out-of-tree volumes. Your in-tree volumes are linked, compiled, built, and shipped with Kubernetes. So all those volume types that we saw there are in-tree volume types. Even from vendors like Red Hat with Ceph or Flocker, those are code that is built into Kubernetes and shipped with Kubernetes. Then you have out-of-tree. And there are two types of out-of-tree. You have Flex volume. Flex volume has some issues because it requires access to the root file system with the control plane and worker nodes. And it's fairly difficult to deploy. And also the external dependencies of whatever the Flex volume driver requires come with it. To solve that problem, the Kubernetes community has come up with CSI, or container storage interface, so much like CNI, which is a container networking interface, to standardize, to create a standardized mechanism for networking. This is a standardized mechanism for storage. So this is being worked on by the various different cloud vendors, Mesosphere, Kubernetes, Docker Swarm. They're all going to understand CSI. So standardized mechanism, sidecar containers provided by CSI drivers with Kubernetes. It's currently beta in 1.10 since 1.10, so it's beta in 1.11 as well, and it was alpha in 1.9. So depending on which version of Kubernetes you're working with, you may or may not have access to CSI as well. So I'm about to jump into example one, but do we have any questions before I jump in?
So we do have one that's come in from Anthony, and it says, does Rancher support Azure managed disks?
So it does support, if I go back to my volume types, we do have the option of Azure Disk. And I believe when you create the Azure Disk, you can also create it as a managed disk. So I believe the answer for that is yes. I've not worked with that directly, but I believe that will work just fine. I'd have to double check that with Azure and their provisioner.
Okay.
Anything else?
Nope, that's it for now. Okay.
So this example, I'm going to create a number of different types of volumes here within Kubernetes. So let me open up my Rancher system. Log in. And you can see here I have a number of different clusters loaded between Azure Kubernetes Service, DigitalOcean, GKE, and a private cluster, which is currently not communicating, probably because I have a VPN turned off that I would normally have for that cluster. But let's do some work here. So I'm going to go to my GKE cluster, and we'll see what storage options are included right away. So there are no persistent volumes. I'm not going to create any here, but out of the box, when we import a GKE platform, we get this standard Google persistent disk. If we're to edit it, we would see the only selectable volume type here is you have standard and SSD. If I were working with another storage class, say Amazon, let's say we look at the Amazon driver. The Amazon driver has a lot more options. So like I said earlier, your volume, the things your volume type support will depend on the vendor and the driver. So let's go ahead and go into my default project, and we're going to create a couple different resources. So I'm going to create a config map here. Like I said, there's a key value pair. And I'm just going to create key 1, key 2, value 1, key 2, value 2. In the default namespace, I'm going to save that. And I'm also going to create a secret as well. So we'll talk about config maps and secrets. You see this looks a lot like the config map area because they're essentially underlying within Kubernetes almost the same thing, except one is encrypted and one is not. And then we'll save. And then you'll notice once these are created, I see the keys. But if I edit them, I can't see the values. So let's create a workload. So I'm just going to create a simple Nginx container or a Ubuntu container because it will load pretty fast. And we're going to create a couple different volume types here. So I'm going to add an ephemeral volume. And I'm going to use an empty dir. So in this case, this ephemeral volume will last for as long as the pod hangs around, and that's just fine. And then we'll go away. And then let's add another one. We're going to add one for my secret. And then we're going to add one from a config map. Oh, I didn't choose my secret. Choose my secret. All keys. All keys. And then I'll add another volume for something on the host. This is so we'll bind mount directly from the node, and we'll show off etcd because there's always stuff in Etsy. There's always stuff in Etsy.
Jason, can I just interrupt you while we're in this point? So we've had a couple of questions coming in. Secrets. So secrets are base 64 encoded, not encrypted, correct?
They are base 64 encoded. They are only encrypted at rest if you have etcd set up to be encrypted at rest.
Okay. And what type of encryption is used for the volumes? Is it the same as for Kubernetes?
Yes, these are Kubernetes volumes. Now, once inside the container, those secret items are decrypted. So if you want stronger encryption than Kubernetes provides, if you have some sort of NIST compliance issue or FIPS compliant issue, I would look at some of the higher end key value stores with that can integrate Kubernetes, like a HashiCorp Vault, for example.
Okay, fantastic. Thank you.
All right. So, what did I do wrong? Host path required, name not found, Etsy. Oh, I did this wrong. Excuse me. Etsy mounts. Thank you for catching my mistake. And wait for Ubuntu to spin up. And we'll actually go inside the container itself, execute shell, so we can take a look at these different volumes. Chris, is this large enough?
It is. I can see it fine. You maybe zoom in one bit, just for people with lower res screens. Yeah, that's perfect.
All right. So if I do an ls here, you can see I have mounted my config map, my ephemeral volume, my secret, and my Etsy mount. So if I actually go into, I can see all the things that are Etsy on the local machine. Now, this is only possible if you don't have a pod security policy keeping you from doing this. So I have a privileged container that allows me to do this and actually see the host machine. I can block that via pod security policy if it's a security issue. So I'm going to go back. We'll take a look at my secret. And you'll see here I have my encrypted key and my encrypted key 2. Oops, and if I show that off, you can see right here, where did the value go? Up over here. So there's my value. If I hit 2, there's my value 2. I can't go and change those secrets from within the file system. They're read-only. And then I have my empty volume, which is there just for use by my application while it's running, and then it's gone. And then the config map works just like the secret. Now, a common use for secrets is to use a TLS cert and key is pretty common use for secrets in this scenario. That way, your application, if they need to expose a cert, they can do it that way, or CA certs, things of that nature. Any questions before I move back to my slides?
So we've got a generic one, and it's one that we in the field come across regularly. It's actually been asked sort of in 2 slightly different ways. But basically, it's regarding databases and what storage we would recommend running databases and containers on Kubernetes.
So state in Kubernetes is generally difficult. I would have said a year ago, don't do it at all. We're now at the point where it's difficult, it's not impossible. So storage, it depends on your database vendor. Whether you need block storage or file system storage, what kind of file system latency that your database can handle. So some research that needs to go into that. So if you need block storage, you need to have an underlying driver that supports block storage, because not all of them do. And the same thing goes for file system storage, depending on speed. For example, the NFS client will work pretty much everywhere, but it's slow, and it will drag down the things like a database might need within Kubernetes. So it also when you're in cloud provider land. For databases, you're probably going to want SSD over standard, unless it's something that doesn't change very often. Is there mostly for archive purposes. So there's a lot of questions that go into that specific question that are business case specific.
Yeah, absolutely, and I'd sort of echo that. In the sort of customers that we've seen, is all I can say is test it. And make sure you do some performance and volume testing on the application before you go live, just to ensure that it does give you that throughput. In some instances, it can be better not to containerize something. It really is one of those things that's a very open question. Cheers, Jason.
All right. So now we'll move on to persistent volumes. This is where we're actually talking about the files that will stick around outside of the life cycle of pods. So they represent distinct storage provisioned by either the administrator in a static provisioning scenario, or by a provisioner, which is dynamic. So a provisioner actually acts as a mechanism that will provision storage on behalf of the pod when the pod asks for it. And as I said, the life cycle is independent of the pods that are using the persistent volumes. Again, there are lots of persistent volume types, just like there are lots of volume types, but you'll notice there are less of them. I just wanted to note here that host path, there is a persistent volume for host path. It's for single node testing only. I put that there because it's come up in POCs before. It will not work for multi-node cluster in any way. Also to say, each of these different persistent volume types have different capabilities. Some of them support multi-nodes, some of them don't. So again, it's one of those read the docs type of scenarios. Some can be resized. It's a beta feature. Your mount options will vary. Again, read the docs. And if I were to go into the Kubernetes docs around persistent volumes, you can see some of them support the volume plugins. Some support read write once, read write many, read only many, depending on the volume and the driver. See, Azure files can do all 3. Azure Disk can only do read write on one specific node. The life cycle. So there are 4 states of persistent volume. You have it available. So it's a persistent volume that is not bound to a claim yet. You have a bound persistent volume that's bound to a persistent volume claim. There's a 1-to-1 ratio between persistent volume and persistent volume claim. Think of the persistent volume like you think of a node, or like you think of a CPU. This is a resource that can be used by pods within your service mesh. Think of your persistent volume claim as the pod asking for a persistent volume. So it may know it by name, or it may not. But just know there's a 1-to-1 relationship between persistent volume claim. So you have available, bound, then released. the claim itself has been deleted, but the persistent volume is not yet reclaimed by the cluster, and that will depend on the the retention policy and other things. But in this case, a release persistent volume will stay connected to the cluster until it's actually reclaimed either manually by administrator or dynamically by a provisioner, and then it failed. Something about the automatic reclamation process has failed, requires manual intervention from an administrator to get going. Again, we talked about reclaim policy. Retain says, hey, when I get rid of the pods and I no longer have my persistent volume claim and I delete my persistent volume claim, my persistent volume is still around. You have to manually reclaim those resources. An administrator has to go out there and make sure that go out and clear out the volume or the directory underlying the pod, and then actually decide to either delete or archive or do whatever with the file system, and then tell Kubernetes it's gone. Recycle, don't use this. It's largely unsupported by the drivers. It's been deprecated. It's still part of the old APIs, so just don't use it. But there used to be this concept where you could recycle an existing claim where, like, for example, for an NFS directory, the NFS directory would be cleared and then reused. And then delete. Underlying storage mechanism is deleted. So like in Azure file or Azure disk that gets deleted, then it would actually go ahead and delete the disk. Provisioner would delete the disk when the persistent volume claim was gone. Again, as far as which one to use, this is one of those business use case situations. If you want everything automated and everything automatic, delete is fine. The problem is that when the PVCs get deleted, the persistent volumes get deleted, the underlying file systems are deleted. So there's a lack of a safety mechanism in there. Retain, you have your safety mechanism and your volumes don't go away, but then it's somebody's job that has to go through either an automated processes job or an actual human being's job to go and clean up those persistent volumes. Any questions before I move into storage classes?
There currently isn't any.
Okay, awesome. So storage classes. This gives an administrator the ability to create different storage offerings. So for each driver, you'll be offering a certain type of storage. Because, for example, we looked at the Google disks, and we had standard when we came in. I could also offer an SSD and have two different storage classes that connect to the same driver, but two different configuration styles for that driver. And then it can be attached, to statically provisioned persistent volume, so actually creating a persistent volume, or triggering dynamic provisioning of a persistent volume. So storage class internal provisioners. These are all the provisioners that come with Kubernetes. So these are your in-tree internal provisioners. So you have AWS, Azure, all of your cloud providers. Then you have some Gluster and Cinder and a couple other volume types out there, including vSphere and Portworx. And the external provisioners, and I put the link down there at the bottom, GitHub, Kubernetes Incubator, external storage. This sub-project within Kubernetes is other provisioners that can be added to Kubernetes at runtime. We'll actually add the NFS provisioner as an example here in a moment. But things like DigitalOcean, which they got into the Kubernetes game later, Ceph, and then you've also Flex Provisioner. So Flex Provisioner allows you to actually create custom provisioners. But again, it comes with the same problems that Flex Volumes come with, in that you have to have root access to or you have to have access through a file system. You have external dependencies. So it's not like the CSI, which is more flexible but still very young. So example 2. We'll look at a storage class. We'll create a storage class, and we'll talk about both statically provisioned storage and dynamically provisioned storage. So I'm back into my Rancher cluster. I'm going to drop down to the cluster level. And we go to storage. You can see I already have Google Persistent Disk because this is a GKE platform, so it already has the Google Disk with it. But let's add a second storage class here. So I'm going to go down and I'm going to drop down my provisioner to my Google Persistent Disk. And just a heads up, and I'm only saying it because people have done this before, even though it seems like it'd be a rather foolish thing to do. Your AWS provisioner will not work in GKE. Your Azure provisioner will not work in GKE, and vice versa. That would seem like an obvious thing, but I've seen people try it, so I just want to say that explicitly now. So I'm going to create an SSD volume type. I'm going to do automatic zone. I'm going to have my delete policy here. No mount options. I'm going to call this SSD. So here now I have two separate different types of storage options in this default storage class. That's important because when I create my pods, if I don't specify a storage class, the default, but I want to do it based on storage class, the default will be used. So in a YAML scenario, this would be if I said storage class colon empty string, then the default is this would be interpreted as yes, I want to go use the default. So let's create some more workloads. We'll create a new Ubuntu. Actually, you know what? Let me go actually create one by. I'm going to do one that is a actually create a persistent volume. So I'm going to create a persistent volume. Choose a volume plugin. Google persistent disk. 10 gigabytes is fine. ext4 is fine, and we'll give it a disk name, my disk. And I'm going to customize that. Single read write is fine. So we'll do all three, and I can't remember if this actually it supports all three. Actually, that's why we have the documentation. It supports read-only many and read-write once, so that will actually fail to provision if I ask for it later like that. So we're going to do many read-only and single read-write, and we can either assign it to a storage class, and it will actually, if somebody asks for storage based on that class, they'll get a already provisioned volume ahead of a dynamically provisioned volume. That's for speed's sake. And then we can use node affinity to actually pick which node it lives on, but we're not going to do that. So, and we're also going to say no storage class here, and we're going to save that persistent volume. And what did I forget? Oh, I always forget this. So if I'm going to manually create a persistent volume, then I have to actually pre-create the disk. So let's go actually out on GKE. Go to my console, and I believe this was under this project that I've been working on all week. Let me check to make sure I'm in the right project by going to my Kubernetes clusters. I should see a GKE imported cluster here. I do. Actually, I could also create persistent storage from within here, and Rancher will see it just the same. And I'm going to create storage. I actually forget where this is. It's been a while since I've done it from the back end first. So I'm going to skip static provisioning for now, only just for sake of time. But the idea being that I could select this manually later, or I can have a dynamic provisioner via storage class pick it up along the way. But again, we have our two storage classes, SSD and standard. And let's actually go and force the provisioner to create one dynamically for us. So Nginx is nice and small.
Sorry, Jason, just while you're doing that, just a quick question. So we've had someone question, the non-storage class means it will use the default class. So when you were specifying the storage class in the last pane?
Yeah, well, and actually in this case, if I go back to, here, let's duplicate this so I don't lose that state. So we're talking about storage class. So in this case, when I'm creating persistent volumes, if you set it to no storage class, in this case it won't use a storage class at all. So it's not assigned to a storage class. A pod asking for a storage class cannot use this specific persistent volume. A persistent volume that is not attached to a storage class has to be asked for by name. When I'm talking about the default storage class being used, that's within the pod spec definition. I'll show that off in a moment.
Thank you. That's
so
all.
Yeah, good question for clarity there.
Cheers.
So I'm going to add a new persistent volume claim. I'm going to use a storage class. I can use a default class, or I can specify a class. I'm just going to create a little small 2 GB And those are fine. I'm going to define that, my Google disk. And I said new claim, did I say the default? Yeah, I did say use default class. So I wanted that specifically. So I'm going to add a second volume, added persistent volume claim. I'm going to create an SSD disk and actually set a class. And do the same here. We know that. So if I were to hit this access mode here, it would actually fail to provision. I get an error during provisioning because the driver doesn't support that. And then we'll launch these. And if we were to, depending on how fast this goes, we could see the events going on in the deployment. We scale the replica setup, and there would be events within Kubernetes. Or in kubectl, if we looked at it to actually see the dynamic provisioning. The dynamic provisioning of the disks within Google. So it's still the provisioner, because it's dynamically provisioning storage, takes a moment. I'm actually going to make sure it's doing its job, but because we can actually look, and as the persistent volumes are created, if we go into the GKE cluster, and we can see them right here. It says disks were created and you see they're bound. If I go back here, all of a sudden my Nginx is up and running. And let's take a look at the shell. And you can see I have my Google disk and my SSD disk. So I have a lost and found there. And let's see if I can write here. And then we'll go back one, and we'll go in the SSD disk. And so now we've written something with these disks, and they will persist beyond the pod lifetime. So if I were to actually remove this pod, or remove any of the pods here, or change this, the underlying persistent volumes would stick around. But I can also I can actually have other applications use that disk as well. So if I want to deploy another application, go into persistent volumes, and I can actually use an existing persistent volumes claim. I don't have to mount it to the same point. And I can select the claim, my SSD disk, for example, and then we'll launch that. And this will go a lot faster because the mount is already created. All it has to do is hook it up within Google, which takes less time than provisioning it from scratch, but still not instant. You can see if I go up into here, there are no more persistent volumes created. And I might have hit, let's make sure I didn't hit an error here. So nothing in here. Let's look at the events. Replica set. This is just taking its time. We've got 2 bound. Still waiting for no availability. And perhaps I've done something wrong in my configuration. So let's take a look at the kubectl logs. We're going to pop into the cluster, launch kubectl, see if I did something wrong here. We'll know pretty quickly if we do the main events. So mount volume succeeded. Everything looks okay. Was it just taking its good old time and I'm being impatient? No, there is something wrong here. Unready status, unavailable. This should have taken a lot less time. Taking the events. See, I would expect to see an unbound persistent volume issue here, and I'm not seeing that. Nor am I seeing anything in here. Oh, pod hasn't bound. Okay, there it is, warning. So for some reason, we have an unbound persistent volume claim. I'm guessing that I'm talking to the driver wrong because, attach failed. There it is now. Disk resource is already being used. So yeah, so it doesn't want to share. So I've configured this in such a way where it doesn't want to share, and that's just fine. But at least we know in this case that I cannot share. Let's edit that real quick and see if we can actually get it to to share. So we're going to remove this claim here, remove them out, remove the volume, add the existing persistent volume claim, set it to read only, and see if that will it'll allow that. It may or may not.
Hey Jason, if you want to share this volume, probably you need to set both and the next to the read only rather than just this one.
To the what?
Volume. Both volume need to be set as a read only.
Oh, and that's what I did wrong. I didn't set this one as a read only. That's right. Yeah, because it only does multi-read only. Good catch. Thank you. Yes, I was offending the driver.
Jason, can we just ask a couple of questions while you're waiting for this?
Sure thing.
So when we do get a pod up and running, could you run a df-h so that we can see how it's mounted within the pod?
Sure thing.
Yeah. Is there an easy way to handle EBS volumes when nodes are divided across availability zones?
So I have to look at the drive. Let's say look at the volume driver. That's a good question. I'm gonna let that do its thing, and it may just take a while because it's. I've offended the driver.
Sure you can spread it. Yeah, I don't know if you can spread an EBS volume across multiple availability zones.
Yeah, I don't believe that's possible. Let's at least look at the volume driver, see what's available. So I believe that. Oh, no, that's for persistent volumes. I want a straight volume. So I'll look at the volume itself. So if I actually create a volume here.
That's not going to give you an EBS one, though, is it?
No, it won't give me any. Well, I can't create one because within the Google platform. Yeah, I don't think it's possible to span availability zones just because you're dealing with nodes in two different areas. But yeah. I've offended the Google driver, so we're just going to clean up this one and let it reattach here just to show that I can use an existing claim. Because if you notice my existing persistent volume claims are still around. They're still bound. Because I have other claims against them, and because my policy is set such that they will stick around beyond the pod lifecycle, or specifically stick around beyond the pod lifecycle, as the lifecycle is not connected.
Okay. Have you got any idea of what kind of IOPS you get through the Google Drive provider?
Honestly, it's too variable to know without testing because. You don't know where your Google Drive is going to end up, in what data center it's going to end up with, the throughput or the hardware that the drive is running on. Those will all vary. So it's one of those, do the due diligence as an engineer, set up an IO test, and then set up an IO test across data centers to get a rough average of what the IO looks like.
Yeah. Okay. And
look at what happened with Azure just 2 weeks ago, where they lost their South Central data center. Operations on everything was different for a week because Azure RM and Azure Service or AD were all down.
Okay. So Alex is asking if this statement is true. So is this accurate? One-to-one relationship between PVs and PVCs, but PVCs can be bound to multiple pods if it has multi-read or multi-write capabilities.
Correct. That is correct. Yeah, I can claim the same persistent volume. Two different pods can claim it. So in my case, I can't because the Google driver doesn't let me do that. To show off another external driver here, we talked a little bit about the NFS provisioner earlier. I only point this out because if you don't want to expose storage right away, but you want your developers to test with storage, there's this nice NFS provisioner, and it's the outage-free plugin we talked about earlier. And I'm just going to launch that here. Now, hopefully, it doesn't change my default. It might try though. If I go into storage class, I get a new storage class for provisioner. Oh, that's fun. I have a double default. Let's reset the default. There we go. And I'm just going to do it on both of them, just to be safe.
One question on that. So for NFS persistent volumes via an NFS share on a host somewhere, in a multi-node cluster, what is the best practice for read-write settings if it were to be used by a database, if it was to be used by database stateful set containers?
Yeah, don't do that. that sounds like a for disaster to use NFS to back a database and then do rewrite.
Yeah,
especially I would find yourself a different storage driver and a different storage provisioner than to try doing that. I think you're going to end up with pain.
Yeah, I mean, we've got a couple of sort of along the same sort of lines, I guess, is what would be a good option for bare metal, and also what's the most production ready sort of Kubernetes storage that you found for on-prem?
So, I mean, it's going to depend on what you need, whether it's block level storage or file system storage. All the different providers offer different functionality. Ceph is pretty darn mature. It's been around a long time. It's got the entry volume plugin. We've seen good success in some of our POCs with Ceph. I've had good success with Minio. I like Minio because it has an S3 style API, so I can write things against S3 that work both behind the data center and within Amazon. But keep your eye on some of your newer projects. There are a bunch of storage level projects that are either in development or in alpha that are trying to one up the existing paradigms. There's one out there called, I think it's like Infinite SH or something like that, where they want to do file system block all in one paradigm and have a very flexible driver that is still can work with SANs and those sorts of things.
Awesome. Okay, I think that's it for now.
All right. So one final thing before I go with the NFS provisioner. The NFS provisioner, like I said, this is different from the NFS client provisioner. So if I were to go out to that external Kubernetes external storage subproject, the incubator, they don't use the term incubator anymore now, it's subprojects. The difference here between NFS and NFS client, so I'm using the NFS provisioner. This is dynamically creating NFS servers within Kubernetes as needed. That's different from the NFS client provisioner, which has to have an existing NFS server to attach to. This one, I would say, you can use this for production workloads. This one, do not use for production workloads. So this one is a development only, persistent volume store. So I'm going to go back in, and yes, I know I've made it very, very angry. And so my NFS provisioner is still updating the workload. Let's delete this. Interesting. We've created pods. So these NFS provisioner pods actually can spin up NFS servers on the fly. I'm not sure why they're taking a very long time to spin up, which is unusual. I'm actually going to see what's going on. I wonder if my cluster is just in a weird state. So let me jump over to my other cluster. Do I already have the NFS provisioner here? I may have the NFS. Nope, I don't have it here. So let's go back into my default. I'm going to launch that catalog app. I always keep multiple clusters around in case I do, injure a cluster, make a cluster angry, which I've apparently done in this Google cluster. I've been using it all week for various experiments. So there we go. So this is a single node cluster. So I have one provisioner, which is just fine for our needs. And we're going to create a workload. And we're going to create a persistent volume. Use the provisioner, 2 gigs. And I wanted to do this so I could show off DF. So I want to execute a shell in here, and I do a DF. You can see here I have my temp FS mounts, but also have my PVC here that was created on the fly. And you'll notice that it's a lot more than, the storage is actually based on what's in the NFS server itself, not what the container can see. And this is specific to DF itself. DF actually looks at the underlying file system, not inside the container. So, you won't get quite the same sizes that you would expect in here. But you can see it's mounted via NFS. If I go back to one of my Google disks, because you did ask about that as well, we'll just tell the provisioner to stop doing what it was doing, and we'll create a dynamically provisioned disk here. And I'm going to create a new PVC here, use the SSD claim, and we'll just do single node is fine, up capacity, 2, define, mount, and launch. And we'll give that a moment to go ahead and create what it needs. Unbound persist volume claim, it's because the provisioner is still doing its job. So I go out to the cluster and go to storage. You see we don't have that third persistent volume yet. And there's my third. Back to my workload. Pod is still spinning up, so it has to still mount the persistent volume claim that was created. And as soon as that comes up, I'll attach to it into a DF, because I just had a question around that. There it is, active, shell. And we can see that now is actually dev SDB. So from a Google perspective, now this one actually does look like it's 2 gigabytes. Yep, or gigabytes in that case, I think it was, and is fully available and matches, because that's just the difference between the Google driver and the NFS driver. Any more questions? Because that's the end of my my slideshow.
So we do have just one question. We've got Olivier, who's asked, I'm interested to build a small cloud based on exascale API, but they don't provide supported external storage like AWS or GCE provides. What are the best practices to manage shared storage in that case?
That's a great question. It's something I thought over. So best practice for shared storage. Just in general, not even just exabyte, but shared storage is, keep mindful of who can see what. Making sure from a security perspective that the underlying blocks, underlying file shares are only viewable by the users that you want to use. Take advantage of pod security policies to make sure that pods that see sensitive data are running as specific service accounts. Other than that, it's read your documentation, know your storage solution before you start using it, because otherwise you're running gotchas like I ran into here, where even though I thought I knew it right, I set it up wrong and configured it wrong, and then ran into issues.
Yeah. Okay. So another one just come in. We have used standalone Docker containers running small Oracle databases with data files on NFS. The NFS filer provides snapshot rollback, and Oracle uses the direct NFS client built into Oracle, which works great. So making this generic question, if I have a storage solution run it okay in Docker, will it probably work okay in Rancher / Kubernetes?
Most likely, yes. It just depends on the storage driver. I don't know. So I don't know if Docker is using the same NFS storage driver. I would assume not. But it's certainly worth testing out. If you're seeing success with NFS and Oracle inside of just a Docker container, then by all means try it in Kubernetes, because under the covers, the engine is still Docker.
Fantastic. Okay, I think that's all of the storage ones related to you. We've got a couple of Longhorn ones come in, but I'm going to wait until Sheng's gone through what he's going to go through before we sort of come back to those ones. So thank you very much, Jason. What I'll do is I will change the organizer to Sheng. So Sheng, you should be able to present.
Sure. Can you hear me okay?
We can.
Okay. So, yeah, see my slide?
Sorry, gone on mute. Yes, we can.
Yeah, can you see my slide?
Yes.
Okay. So I'm going to talk about what is the current status of the container storage, and I will going to talk about some solutions you are going to probably some choice you're going to make, and I give some information of that. What's the expertise for each of vendors and what the specialty about that. But I think at first everybody agree that if you want to use container, you still need some storage thing to persist your data. And we all know that container is great for stateless workload, but as I said, it's hard to live a meaningful life with amnesia. So you got to, at the end of the day, you got to store your database or key value store application specific data to some place. And the current choices, if you go with the cloud computing with the cloud computing vendors, that's Google, AWS, Azure, they already have some solution for that. For Google, it's persistent data. AWS is EBS and EFS. Azure is the Azure File and Azure Disk. So all these options already embedded in their offering, and either it's as a Kubernetes service or just add on to your virtual machines, which can be called by the Kubernetes drivers. And the other choice you have is if you go with basically go with Red Hat, because Sapphire cluster both owned by the Red Hat. So if you want to get logged into the Red Hat ecosystem, you use Red Hat and OpenShift as the RHEL and OpenShift as your OS Kubernetes vendor. You can go with the Sapphire cluster, and the cluster is the difference between the Sapphire cluster. For if people don't know, the Sapphire is basically provides a block storage called RBD, and the cluster is provide distributed file system. As Jason mentioned before, the main differences between the two is the block device normally has a high performance, but the block device can only be used by one node. There's no way to share the block device across different nodes, because when you're using a block device, and top layer is a file system, local file system existing there, and you cannot change the block storage without the file system knowing. That will cause data corruption. So that's also why if you want to use a database which cannot be scaled horizontally, you don't want to use the distributed file system for that database, because if you have multiple instances writing to that database, database is going to be corrupted. So, but for the other case, the distributed file system allow you to, like a cluster and NFS, allow you to simultaneously read-write from multiple nodes. And even though the performance is less than ideal, but it's very flexible and easier to use. Also, you have a traditional storage vendor like NetApp EMC, which they sell their dedicated storage boxes, and you connect that to your network, and they also provide plugins or drivers to connect to your Kubernetes deployment to their own storages. And you have a hyper-converged infrastructure like Nutanix doing the same thing. Other than that, currently there's a bunch of new containerized storage solution, which is enabled by the Kubernetes and the Docker, and the provide service to them, including Longhorn, Portworx, Corebyte, StorageOS, Ruco, EBS. We're going to talk a lot more about Longhorn later, and I will talk about the others now. So the Portworx is also provided block level storage, which means it's high performance, but a single node read write only. And they also the kernel part there. So there's one challenge for the block level storage, that is you have to expose a block device on the host. which there are a couple of ways to do it, but what's the Ceph has which basically means you have to have some way to access to the Linux kernel to do it. The Ceph has RBD built in the kernel, and there's this module which enables Ceph to provide block device to you. Portalworks build their own kernel modules to do that, but you know that they didn't upstream. At least they haven't upstreamed the change yet. So you have to recompile the kernel module every time if you are going to install that on the new machine. So the kernel won't become, the kernel will still the same, but you'll take time and take there a lot of effort to maintain the modules compatibility against the different Linux kernels. Corebyte is doing the distributed file system. Storage OS is also providing the block storage, and the storage OS, the kernel part currently is using something called the TCMU, which in fact we wrote for Longhorn a long time ago. And at the time, we had the choice to go with the TCMU. Some background here: the TCM is the currently de facto Linux kernel standard for the in-target iSCSI target. In kernel iSCSI target. So TCMU is basically expose that target and with the interface to the user space, and then you can feed the data through the user space through the TCMU interface and present it as the block device. I think we got it merged in the Linux upstream at around 4.16. But the thing is, we think about that. We reconsider our decision about make a compromise between the performance and the availability, because we don't want to say that user below the certain version of Linux kernel, then you cannot use Longhorn. So that's some situation we want to avoid. So we decide to go to other paths, which is involving using the iSCSI. Create a user space iSCSI target using TGT. So the storage OS, they think our works are great, and they are using the TCMU right now, and I think it works great for them. And the Rook, I know the Rook is getting accepted in the CNCF, but the Rook itself is basically an orchestration layer on top of Ceph. The Rook doesn't deal with data plane anything, but it just make it easier for you to deploy Ceph on the in the Kubernetes cluster. But to us, one of the reasons we create Longhorn, and also there are some other containers that's like the Portalworks storage OS for the block storage, is because Ceph is kind of complex to us, and all this kind of setups and this complexity involved make we think that this should be some room for improvement. So that's we create Longhorn, and probably the other storage vendors think the same. So the last is OpenEBS. In fact, the OpenEBS is based on the technology of Longhorn, at least for now. We pitched them the Longhorn data plane, the Longhorn engine about a couple years ago, and they like it, they really like it, and they starting to building business around it and building up and doing the orchestration part. And now we are also began to work more to push at the Longhorn and to make it more appealable and easy to use to the customer. I think OpenEBS is currently turning to another different fundamental, another different solution for the underlying data plane. So we'll see how that goes. Any questions?
So currently now we've got a specific Longhorn one, where I'm going to let you get through the Longhorn stuff before I check that across.
Okay, sure. All right, so I will give you an overview of the Longhorn data plane and the management plane. It's just basically Longhorn architectures and basically how Longhorn works. And after that, we'll go through some demos. So assuming you have two hosts here, you can see that both hosts have some hard drive and some CPU and memory. And when you create one container and you want, of course, you want the volume for it, and the volume concept here is more likely the one in the Docker rather than in the Kubernetes. You say that you have volume, you have a persistent volume, you have persistent volume claim, storage gas, whatever. But this volume here is basically you just think about that is the directory somehow mounted inside the container and contains data which can be persistent. And this volume, if we want to have this volume, we are going to create one volume, one Longhorn controller and 2 replicas for you. And the Longhorn controller is essentially a microservice RAID 1 controller which talk to the different replicas, and the replicas, as its name implies, is replicate the data exactly, but across different hosts. So one node is down, doesn't affect your data. You still controller, the Longhorn controller will talk to another replica to make sure that the operation of that volume still works okay. So that is basically the concept of the Longhorn. So the data plan here, we have one controller and how many replicas we can define. It can be 2, 5, whatever, I think. And also all the data writing the replica is in the synchronized way, but you know, the block storage, the storage layer is already very asynchronized, so the throughput won't be affected by that. The replica need to get synchronized the data writing. And you have another container, and you can see that the replica can use the different disk or the same disk on the different host. And our principle to put a replica is just spreading out and put on different disk, and the controller will talk to the replicas and make sure that everything in sync. If one replica behaves weirdly and got some errors, we'll just cut that replica down. And the management layer, which I'll talk about later, we're going to rebuild that replica and make sure the volume is in the resilient way. Okay, so this is the data plane. One thing I want to emphasize is the data plane itself is resilient by itself. It doesn't need the manager to or other third parties to look into look into it and keep the volumes read right and daily operation is not depends on the other part of Longhorn. But if the one replica is down, assuming you have 3 replicas, 1 replica is down, then you can only afford to lose another replica before the volume goes out. So that's management thing we done in the Longhorn control plane. So the Longhorn manager is what we created here to orchestrate all the controllers. And why is this possible? Only now, not before. Because each controller replica are packaged as a Docker container, and we can depend on the Longhorn manager to reliably distribute these containers on the different hosts, and we can communicate to them with ease only till now. So the manager here we'll have a few iterations about on the manager, and now we're basically building manager with the Kubernetes. It's inside Kubernetes. And we are, no, not quite inside Kubernetes, but we are using the Kubernetes API server and the Kubernetes ICD, which normally you've already been HA'd because you want to have a resilient Kubernetes setup. And the Longhorn manager utilizes the customer resource definition, which the CRD in the Kubernetes to keep a record of these resources and to keep a track of all the controller replica and the volumes, this object. And on the top, the Kubernetes cluster, which is probably, it can be same or the different, the Longhorn manager residing. We'll talk to the manager in using Flex Volume API or Container Storage Interface API. The Flex Volume API is kind of old, and it's not as flexible and easy to use as even it's called Flex Volume. It's not as easy to use as the container storage interface. There's one particular problem we have with the Flex Volume API is because it's supposed to be installed along with the kubelet. So the kubelet have to access the directory which contains the flexible volume driver. That makes it very difficult to distribute it. But finally, I think in the latest Longhorn 0.3.1 release, we have addressed that, and now we can automatically detect the flex volume directory and make sure that if you don't have access to the CSI, the Longhorn still works good for you. So the CSI is the new standard, which is coming out not only in the Kubernetes, but also in other container orchestrators. And the community is reaching consensus on how CSI should be, and it's more easier to manage and are going to be the trend in the future. And also Kubernetes community is moving all the in-tree plugins, like what you said before, the EBS, EFS, everything is going to into the CSI, but CSI is still young. There's a bunch of caveats and the issues with it, but we're looking forward to it getting good. Other than the interaction from the Kubernetes part, we also have very critical part, which is the Longhorn UI. I think we create a very good UI interface, and that dashboard gives you the overview, what's happening in the Longhorn cluster. And the Longhorn UI talking to the Longhorn Longhorn managers through the Longhorn API. And the Longhorn UI will allow you to do the snapshot and backup, this kind of operation, also modify the disk you want to use with the Longhorn storage. So this kind of more high-level operation, which doesn't provide by the Kubernetes, is provided by the Longhorn UI. Okay, any questions?
We have several questions. I'll just start running through a few of them. So the first one, have we got any idea on when we're going to GA Longhorn?
I think probably sometime next year. Currently, the Longhorn is still an alpha quality product, but I think Longhorn 0.3.1 is relatively stable, and we welcome people to try it. And as you can see later, it's very easy to deploy in the Rancher right now. Yeah, but okay. we do have some caveats around how do you uninstall it. And previously, from upgrade from 0.1 or 0.2 to the 0.3 requires some manual upgrade process. But other than that, I think everything's good.
Okay. So a feature request, I think it may be on the roadmap. When will you be able to delete hosts in Longhorn? Right now, if a host died and cannot be rebuilt, all volumes on that host will be stuck and unrepairable.
Okay, so the replica, I don't think the replica will be damaged. I think the only thing you have is if the volume attached to that host, the volume is supposed to be able to be detached. So okay. after detach, you can still attach this volume to other hosts. So if that doesn't work, it's a bug. And another thing is currently we are in the 0.3.1. We are working on removing node feature, which I think we are near to complete, probably in the next release. And we still, because you know that the host down, this kind of operation is kind of hard to test. Every time we need to test it manually, but for the other test cases, we had automation test switch, which I think is running for 2-3 hours right now every time, and it goes through every feature we have. So we definitely will improve on that. But in theory, Longhorn is if you want node is down, you should be able to detach the volume and attach it to another node. So that shouldn't affect anything. And you will have the ability to delete the node soon.
Great, thank you. When will Longhorn run on Rancher OS plus RKE?
Okay, so we had made some effort in the 0.3 for the Rancher OS, but later we found out this the CSI distribution, the CSI way of distribute to the Rancher OS doesn't really work well, so we're still working on that.
Cool. And the last one for now, I think, is We've got Adrian, who is currently working on Longhorn and would like to know how the replicas allocated to volumes, because he often has multiple replicas on the same node while some of the nodes are empty.
Oh, I think if that's the case, there will be a bug, because the policy now is as long as the even if the node has enough space for that, that node should be selected for the replica. So if that's always the case, and you didn't disable the scheduling for the node, or the disk reserve space is not high enough to exclude the replica, there will be a bug. Yeah.
Okay. If you carry on for now, we've got a few more questions, but we'll get through the rest of it and then we can wrap those up later on.
Okay. So for the Longhorn, our design target is focused on the simplicity, reliability, and performance. And that means there's a bunch of things we do and a bunch of things we don't do. For now, the controller doing the mirroring, which is sending the data to the multiple replicas, and they're doing the rebuild, which is once one replica is dead, the controller has the responsibility to copy everything the one replica has to another replica in order to resume the health state of that volume. And the replica, we currently can do snapshot and backup. And in the future, the traffic will be encrypted in the controller and the replica communication, and also the replica will be responsible for some QoS work. And what we don't support, the first one is controller HA, because the controller is always residing in the same node as in the consumer. So if the controller is died, there's definitely something wrong. Definitely something very wrong with that. Is most likely the node is down. And if that's the case, we don't really have a way to do the HA for the controller. But it's a different from other storage solution, because if you say Ceph, there are only 3 process. If you have 3 nodes, there are only, I think, 4 processes running on the 3 nodes, and they don't have one process dedicated to, or multiple processes dedicated to one volume. So in our case, that we are pretty sure that if one controller is down, first it's only affect this volume. Second, it's most likely that node got something wrong. So we don't really do the HA. We don't do the HA for the controller, but you can always sorry. You can always detach the volume and attach it to another node. And we don't do the tiering, stripping, dedupe, compression, all this kind of fancy stuff. And deduping and compression is we partially do that. In fact, we involve a lot of some of that in our backup storage, in the backup mechanism, and in order to reduce the consumption of the secondary storage. I will talk about a little more than that later. All right, let's do the demo. All right, so I'm not sure what the screen size looks like. Should I go bigger?
No, that's good.
Good, okay. All right. So I have a Rancher set up right now running with a managed cluster. And what am I going to demo today is first, I'm going to just install Longhorn. And second, I'm going to demonstrate how to use the Longhorn with the WordPress app and writing things to it, how to preserve it. And finally, I'm going to demo that, how do we restore the backup from the Longhorn. So in fact, the second part also applied to the other persistent volume. In fact, it's not very straightforward how the storage works right now in the Kubernetes, but and I'm writing something for that to clarify that how you should use the storage in the Kubernetes and what does this all kind of things means. But for now, I just bear with me and let's dive into demos. So first, I'm going to create another project, named storage, which is just for the Longhorn. I'm going to, because I don't want this Longhorn system, which is kind of infrastructure, to deploy into the either system or into our default project namespace. So I want to deploy in the storage project in the Rancher, and we're going to launch it. So we just released the 0.3.1 yesterday, and by default, the application will be deployed in the Longhorn system namespace. It cannot be changed because we don't want user to deploy multiple Longhorn system in one cluster. It can cause a lot of trouble. And we're going to use CSI, and mark is the default storage class. Since I'm building this class and the RKE just on the DigitalOcean, it's just no other storage class available. Yeah, let's just launch it. All right, so basically now we just wait for Longhorn to complete the deployment, and you can visit Longhorn's homepage at github/rancher/Longhorn. And here you can find the instruction how to deploy that using YAML. So basically there's two ways we offer to deploy Longhorn. Is either from the catalog app or from the YAML file. All right, I think this is up. Yeah. I can click this to get into the UI right now, but I probably want to do that through our 31560. Yeah. So now you are seeing that just Longhorn UI after you first time deploy it, and the version is 0.3.1. And here the dashboard shows that how many volume we have and what's the storage available for scheduling. And you can see that as part of storage we are reserved. That means that we are trying best not to crouch into that space, because the Kubernetes do have some limitation on how much free space you have in the node before it reach the storage pressure, and how many storage has been used. And the node status is also showing here. And in the node page, you can see that we have 3 nodes right now, and what's the status of each node, how many is being used. And we don't have replica right now. And you can also see the disk we're using for each node. By default, Longhorn is deploying into the varlib the replica, the data of Longhorn are going to store in the varlib Rancher Longhorn. But you can add other disks if you want. And in order to add other disks, you have to format that disk and mount that in some path on the host, and tell Longhorn where the path is. But if you are trying to use the same disk on the node, we just tell you that it's using the same file system. We're smart enough to detect that and make sure that you don't add the wrong disk, result in double account in the scheduling part. And for the volume page, we haven't get anything yet. And the backup is which we show the Longhorn backups, but for now we got error because we haven't set up backup target yet. In order to set the backup target, which is the place we store the backup, you need to provide the backup target URL and the secret if you are using AWS S3 style backup target. So for now I'm going to start a minion. So I'm going to start a minion from command line, and let me see, where is this? Yeah, here we have documentation on how you set up the backup store, and we have one line to set up local testing backup store, and this one will create a minion backup store for you can be used in the Longhorn. And we'll run that in the command line. All right, it's done. So that's the default workload. We should have the minion running. And in the Longhorn, we are going to fill in the parameters here. And the minion secret is the secret currently embedded in that YAML file. It's just some testing words. It's supposed to contain your access key and the secret key for your AWS. Okay, now we look at the backup. No more error message, but we don't have any backup yet, so there's no volume. Now we can just create some volume just for testing purposes. Okay, volume created in detached mode. Back to the dashboard. Yeah, you have one volume here. Is it detached? Nothing changed. And just attached to one node. And here, I'm not using Kubernetes. I'm just using Longhorn to do the volume creation, attach, detach, and other operations, because the Longhorn itself it can work independent of Kubernetes and provide your block storage in the ways just as a raw block device. Say that now you can see that in the test, this test volume, it will show up on the this node host and as the block device /dev/longhorn/test, and they have 3 replicas running. And now I can just take a snapshot. The snapshot in the Longhorn is instantly, so it's all one operation. And the snapshot is kept with the data with the replicas. So if you want to create the backup, what Longhorn do is just they create the snapshot first and the backup the snapshot in the backup store. I can just do the create backup here. So this one should be fine because we don't really write anything into that, so the size is 0. But now the backup showing that we have volume test here, and it can be what's this snapshot being created, and what's snapshot name, and it can be restored later. Another thing I want to show that is for any volume in the Longhorn, you can in fact just scheduling recurring snapshot and backup, and just create one backup every minutes for retain 3, means I only retain 3 of the latest backup created by this recurring backup item. And we can check on that later. But yeah, probably take a few minutes to show what is there. All right. Any questions?
We do have a few more questions. So we've got a question from Patrick. How will data be back in sync after host loss? And more importantly, how does the controller know which host provides the right data?
So first, if one host in your replicas, for example, you have 3 hosts, you have 3 replicas. Even if one host of that in that 3 replicas it doesn't die, so the controller knows that one is the right one. But if all of your hosts are dead, so we have a revision count in each of replica. So when you connect to those replicas, the controller will figure out who has the highest revision count and use that as the latest result. It's not guaranteed to be 100% correct, but yeah, this just is the most disastrous scenario. We're trying our best.
Okay, cool. I've got a question from Michael. So he says, I've ended up with 3 replicas of volume running on the same node. Is it possible to move 2 replicas to 2 other nodes without destroying the volume?
Yes, in fact, it's pretty easy. Now I have 3 okay, you can see that the backup is coming. So you now have I have 3 replicas on the 3 nodes right now. So first thing, you need to make sure that the other 2 nodes indeed can be scheduled to create a replica. So as I said, if the nodes seem to you they can have enough space to create this replica, but it doesn't print on that, that's about we're still hunting for them. So and if you want to move one node, you just you can manually delete it, And what happens after is going to trigger Longhorn's rebuild mechanism, and Longhorn will try to find another proper host to place this replica, and they were going to copy the exact same content from the previous replicas to that node. So just yeah, I think let's know this host is replica is gone, and the Longhorn is rebuilding, and is starting a new replica, and still on the demo 3 because demo 1, demo 2 have been taken.
Okay, great.
It should be finished soon, right? Because we have no data in that. Okay.
Fantastic. Okay, so we've got Danielle has asked, can Longhorn be used by applications not running in containers?
Yes, because the Longhorn itself is basically just expose the block device on the host. You can use it in the way whatever you want, and the Longhorn also have ability to expose as an iSCSI target. You still need to attach it somewhere, otherwise the containers won't be running. But you can see that if the front end is iSCSI target, I'm doing the attaching to node 2, and it will show the endpoint. The endpoint is basically the IP address of that the container, which means you have to have the network routed to your host, and what is the IQN of the Longhorn, and what is the whole iSCSI endpoint you needed to connect to this one. So we're using this for the Rancher VM integration, and also Longhorn supports base image, which means you can just use the Rancher VM and create a base image for Longhorn and run the VM on top of that. We're working on that.
Great. Okay. Is replication synchronous?
Yes, the replication is supposed to always has the same content. Otherwise, it will consider broken or bad.
Okay. Currently, if you delete the default disk and add dedicated disk for it, there's no way to remove that reserved storage. Or is there?
Wow. Okay, so here, you add the disk. Yeah, I think that's a bug. Oh, another thing is you can disable scheduling. After disable, so basically the steps, if you're looking at our documents, the step of removing a disk or node is you have to disable scheduling first and then remove any replica on that. So then the node or disk become empty, then you can remove it. So if it still doesn't work for you, please file a bug.
Okay. So we have another, it's in alpha state. It's possible to use in production if we have a Rancher support without the risk of losing our data. So I would say, I don't think we currently support Longhorn under the Rancher support contract. So eventually it will be in there, but yeah, it's currently not there.
Yeah, currently it's still the work in progress. So we are, we're still actively working on that. And please file bug if you see anything, or just asking in the Slack local storage channel. We're glad to help. Yeah. But now we don't really recommend that for the production.
No. Do you have plans to support file or object storage types within Longhorn?
Sorry, what? I didn't catch that.
Do you have plans to support file or object storage types with Longhorn? I'm guessing we already support file.
Oh, file. Oh, yeah. Yeah. So, okay. So Longhorn itself is a block storage solution. Of course, we will integrate with the Kubernetes. We are going to format it in some format Kubernetes can recognize. So that's already being filed. But as the limitation, as I stated before, as a block storage solution, it can only be attached into the one node. And probably as a block storage, the most we can do is doing the multi-read only, as was the Google persistent disk do, which means you cannot change the content. That's when you can read from the multiple node, but that's the only limitation. So if you want multiple read-write from multiple node, that's only distributed file system can do, like NFS plus FS.
Okay. A follow-up question about exposing it as the iSCSI. It's saying it's only the 1042 visible, so how can you mount that to an external machine using iSCSI?
Yeah, so you have to, so for the rental VM, the rental VM is running inside the Kubernetes container, has the Kubernetes IP address, so it's not a problem for him. But in the other, if you want to use that without using this IP, you probably can do some host node mount, or probably not node balance, but a host node port to expose that out.
Yeah, great. And so what are the minimum speed latency requirements between the Longhorn nodes?
We recommend at least gigabytes. Just don't do, there's a one user is doing that across availability zone, and he has two nodes. One is in the home server, another one is up there after the DSL, which is cause a lot of weird problem. In the future, we're going to detect that and warn you about the network situation. But for now, they just say it's at least gigabytes, because you know that it's very easy to separate the network with the high-speed storage.
Okay, great. And does Longhorn support read-write many disks so that you can use it on multiple pods?
No, as I said, it's not possible for the block storage to support that, read-write many. You have to use some distributed file system for that.
Okay, that's great. That's all the questions we've got at the moment.
Okay, sure. So let's go back for the rancher. Okay, so well, now I'm going to create we are going to create a WordPress app using the Longhorn volume, and before that we need to do some preparation. So there's one caveat with the catalog apps, which is if they are provisioning their own volumes, the app will, if the app was deleted, the volume will be gone with it. So we need to create the volumes for them beforehand, then we can keep them volumes for the future use. So here I'm going to add just namespace, WordPress. I'm going to create two volumes, two PVCs in this namespace, because you remember that the PV is not namespace scope, but the PVC is. So the first one, I'll call wp-wp, WordPress-WordPress. Namespace, put that in the WordPress capacity, 5 GB. The custom, just make sure that the single node read-write is being chosen. Another is called wp-mysql, still with the WordPress default, because default is Longhorn, 5. Yes. Okay, now switch back to the Longhorn UI. You'll see that two volume has been created by the Kubernetes, and the persistent volume name here, we need to note this down because we need to use that later for the restoration. There's some users complain about that the naming. If in the Longhorn, you cannot figure out who it is. Yeah, so that's the reason. That's some thing about the provisioning in the Kubernetes. They never tell the storage vendor what's the claim name or what's the parties using it. We're planning to integrate more to basically get some information through the other through the Kubernetes API in the future to integrate that into Longhorn to make sure to make user easier to see that what is going on with this volume and who this volume is. Okay, so now we have two PVC created. Now let's get started to create a WordPress. Yeah, make sure this WordPress will be put into the WordPress namespace, otherwise they cannot access to pre-created PVCs. Persist volume enabled, size 5 GB, and using the volume WP-WP. Yeah, here same persist volume enabled, 5 GB, WP-MySQL. Yeah, double check. Okay, looks good. Let's get started. Here you can, in fact, looking at the dashboard for Longhorn, and you can see that that 2 volumes in progress right now, which basically means it's either creating, attaching, or detaching. So the Kubernetes is now asking Longhorn to attach these 2 volumes to the related to the corresponding nodes for that pod Kubernetes is going to create. And the Longhorn already done that. The volume has been attached successfully. And here we just wait for the WordPress to get up. We have provided a lot of documents here in the Longhorn. So if you have any trouble working with Longhorn, can look into here. And you can also file a ticket with Longhorn issues. And also we are available at the Slack as Ranger user Slack as a Longhorn storage. And here is if you get any troubles, you have you can see here for the troubleshooting. Sorry. And the most common trouble we have is user cannot specify the flex volume directory correctly, because it's really tricky for the Kubernetes to figure out the directory in the Kubernetes. There was API available, but it was removed in the 1.9. So now we are creating some new mechanism just to detect what's the command line of Kubernetes looks like, in order to figure out what we have installed our flex volume plugin in. And this problem doesn't exist with CSI, but I think the early stage of CSI right now, it's got some other problems. CSI currently official release is still in the beta and in the 1.4. I think probably not going to be GA by the end of the year. The Kubernetes probably community going to GA CSI, I think from next year. And here's a troubleshooting guide. If you have any issues, you can, how do you connect log, which log is critical for you, and this kind of questions. We'll constantly update the documents as well. Okay, the WordPress is up. Let me log in. Yeah, okay. Dashboard is here. Let me just create some new posts. Make sure that is us. Publish it. Here. So we have changed some status of the WordPress, and they're going to write the information into the MariaDB SQL database and also the WordPress itself. Now we're going to, let me see, going to shut down the WordPress and make sure that everything, the volume here is still here. And shut down the WordPress, delete the app, and make sure the volume is still there. You can see that from the dashboard, the volume is going to be detaching by the Kubernetes because the consumer, the pod, is no longer there. Any questions?
So currently there isn't any questions waiting.
Okay, good. Okay, 2 volumes used by the MySQL has been detached. Okay, let's relaunch MySQL using the same volume to see that is the content still there. Right? Oh, no. Yeah, I think everything checks out. Take a look at Longhorn. Okay, start attaching. One is to the demo 3, one is to the demo 2. I think demo 3 is the MySQL, demo 2 is the WordPress. Okay. Let me close this page. No, not yet. Oh, okay. Yes. So now you can see that the previous data was preserved in the persistent storage in the Longhorn. So you can see that the Longhorn demo is still here. And now I'm going to make a backup of that 2 volumes, and later I'm going to delete those 2 volumes and make sure the things are still here. Just create backup. So for the snapshot, it's instantaneously because we keep the snapshot at the same place as the replica. But for the backup, we're going to copy the snapshot from the local disk to the supposedly remote secondary storage. But now it's still in the Kubernetes cluster, but they can be in higher up there in the Amazon S3. So it will take a while. And you can see that this backup is 400 megabytes, which is pretty huge, because I think most of the data here is just you format the 5 GB disk is already being 200 something for the file system informations. And then we're going to make a backup for another one. Well, that's quick. Okay, now we have a 2 volume backup. Now we're safe to delete these 2 volumes. Okay, in order to operate on the volumes, you don't really want to just delete them from here because the Kubernetes doesn't know about that. So you are going to do is we just delete this WordPress first, which is the consumer of these 2 volumes, and the volume will be detached. At the moment, we can take a look at what recurring backup is doing. Seems doing great. Yeah. Because if you remember that before we destroy one replica, which result in the system automatically create a snapshot for the replica rebuild. Now the backup is still the latest backup created a few seconds ago, 1 minute ago, 2 minutes ago, which means we really indeed just preserved the last 3 of backups. Also, it's the same as in the backup store, we only preserve the last 3. Okay, so here the volume has been detached, and now we can remove these 2 volumes. This operation, we're going to delete the volume from the Longhorn as well. Deleting, done, they're gone. So now the Longhorn system itself doesn't have any clue of what this volume is, but we do have copy in the backup store, and we're going to restore that. So heading to the backup store, choosing the PVC-0A. Let me see. The 0A is the WordPress one. So choosing restore, I'm going to do WP-WP, which is the same name we used before. Right. Another one is 1D10. This one is the MySQL. Okay, so both volume has been created and in the detached state right now. At this moment, the data wasn't being transferred back yet. It will be transferred back the first time when you create it. So now we are going to create a persistent volume for this for the two volumes, because we're not using provisioner to automatically create a volume, and we need to use the existing volume for the PVC. So we need to create a persistent volume for that. Unfortunately, we haven't got time for the Rancher to integrate well with CSI plugin. We do have one for the Flex volume plugin for the Longhorn. So now I'm just going to do that through the group control to create the persistent volume PVs for these two volumes in the Longhorn. All right. Yeah. So you can see that the name will keep the name as WP-WP because they're different objects. There's no name collision here. Capacity, volume mode, file system, and read-write only. This is important. It's x84, which is default format for the Longhorn, and the driver here specify that which CSI driver they're going to use. Number of replica 2, which matches was the setting in the Longhorn itself, and the volume handle. This is the name. The volume handle is the name we used in the Longhorn. So this one looks good. I'm going to copy that to make the MySQL one. All right, so looks good. By the way, K is short for kube control. It just short kube control is too long. So we create first persistent volume and the persistent volume for MySQL. Done. Now you can see that in the cluster storage, we have WP-MySQL and WP-WP, two persistent volume. Now we need to create persistent volume claim to use these two volumes in the WordPress namespace. Previously, we just create a new volume using the storage class with the Longhorn storage class. Now we just use the persistent volume claim to bind into a certain persistent volume, which is WP here. And then another volume. Namespace WordPress onto the MySQL. Yeah, now the PVC has been created, and you should know that what will happen next. We're going to launch the MySQL WordPress for it. Still, we want this WordPress into the WordPress namespace. Enabled. Same as before. Double check everything is right. Okay, then let's just wait for it and see if it, yeah. So now we confirm that Kubernetes has successfully connected to these two volumes in the Longhorn by specifying these two volumes as the PV in the Kubernetes. Let's wait for WordPress to deploy. Okay, any questions? So
we've just got a couple of questions. So one, what about in a disaster? When I remove a server node with mounted data or with a replica, does Longhorn go into infinity sleep?
Okay, so it depends on which node is down. If the attached node is down, you can always detach that. Longhorn shouldn't prevent you from detach that node. So if the one replica is down, but the node you attach the volume is still up, you are good. So the volume should still work. If you found behavior otherwise, just let us know.
Great. And is the replication snapshot technique based on an existing solution such as LVM or DRBD, or is it something new?
No, it's something new we created. We created ourselves. It's basically every snapshot is a sparse file, and we are using the internal sparse file layout, which you can get from the kernel information, from some system information, and you use that layout to know that which sparse file contains which part of data, and we combine all that data. So this part of that. So basically, the whole stack of Longhorn we're creating ourselves, and with our system knowledge and kernel knowledge, it's not using any existing things, except, yeah, we are using Docker. Oh, in fact, another part is the iSCSI target we're using right now is the DGT. We create a customer driver to hook Longhorn into the DGT to provide iSCSI. And if you want a block device instead of iSCSI, we are calling the host, the iSCSI admin, to create a block device out of iSCSI for you. It's the most tested, reliable way to create block device, and also well adapted. That's what we think. So that's we choose this way over the TCMU kernel patch we created before. Let's things up. Oh, okay, it works. So the volume has been restored to the original state, and the WordPress is still using it and showing the successful result. Yeah, that's all for today's demo.
Fantastic. Thank you very much, Sheng. Okay, so I'm just going to quickly change the presenter back to me.
Oh, sorry, Chris. In fact, I have a 1-2 slides need to cover.
All right, sorry. Go for it.
Yeah. Okay, so I just need to cover a little bit more about what's current status on the Longhorn and what our plan is. So I think if you join our Meetup in the last year, we have set a lot of goals and time to be done, and most of them has been done now. So the latest release, which we released yesterday, is 0.3.1, and we have Kubernetes support and deployment one click from the Kubernetes, and for the detection, rebuild, snapshot, and now we support backup to the NFS S3 and a very comprehensive UI. And also, it's one interesting feature I want to mention that we now support live upgrade control and the replicas, which I think is really the first in the industry. The reason we can do that is we are packaging the controller and replica into the containers, and we are using some mechanism to lively swap out the binaries. So it's very interesting, but still in the experimental right now. So we need to play with them more to make sure that everything works as expected. And also we have event log, which is we integrate that to the Kubernetes. The event log, you saw that in the dashboard, in fact, it is the feature log from Kubernetes. And the multi-disk management, which is one thing that's in the early this year release, user asking for, and a capacity-based scheduling. So in the future, there's still a bunch of things we need to do. Authentication and the user management. Authentication is mostly can be done by the range itself, but we're trying to figure out what's a better user experience for that. And the user management is pretty critical to the storage as well. You don't want to user A have access to user B, so that's something we need to work on. And the volume encryption, and also we're going to provide the encrypted backup, so you don't worry about that what your data is after you upload it into some other places and losing your precious data, and performance tuning and the volume statistic. We haven't done much on the performance tuning yet. We are more focused on the reliability and the feature set right now. But I think there's a lot of low-hanging fruit right now, and even we haven't done much yet. The performance is not too bad right now. So we can achieve about 100 megabytes or even more on the SSD. So the bottleneck we solve mainly right now is the network speed connected to different node. So that's why I suggest that you have at least have the gigabytes connection for your network. The volume statistic is also something we need to add and to make sure that the user knows that if something goes wrong with the low performance, user will know what it is. Yeah, I think that's all for me. Thank you.
Okay,
thank you, Chris.
Great. Thanks, Sheng. Just one last question has come in. So is there a performance overhead of the controllers on top of the actual workload using Longhorn?
We don't really see much of the overhead right now. Yeah, of course, if anything involving moving the data around, there will be some overhead compared to what you have in the raw disk, but I don't think that's a big problem right now. Yeah, as I said, the performance, we really haven't spent a lot of time doing that right at the moment, but I think it's pretty decent. And the most issues we have right now is around the features and other things. Performance it basically depends on if you have a 10G or more or better network, is probably going to impact. Probably you guys think the performance will be the bottleneck. Yeah, well, of course we are targeting that market as well, but yeah, we'll get to that eventually.
Okay, and are snapshots replicated?
Yeah, snapshots are replicated across all the replicas. So the replica contains data will be exactly the same, including every snapshot. So
Fantastic.
losing one replica won't lose your snapshots.
Great. Okay, so that's all for questions. So I've just got a couple of slides to lock up. So getting started with Rancher, very easy. So prepare a Linux host and then just do a Docker run. We do have quick start guides on the Rancher docs site, so that's at the bottom. So you can go to docs.rancher.com and fire up the Rancher 2.0 documentation. And in there, we've got quick start guides. So we've got quick start guides on deploying via Terraform to AWS and DigitalOcean. We've got manual server steps to walk through, and we also have a Vagrant setup on there. And we also give examples of deploying workloads and exposing them via an ingress and via a node port. Please do get involved. As we said, everything that Rancher does is open source. So Rancher, Rancher OS, RKE, and Longhorn are all in GitHub. So please go in. You can have a look around the code, and it'd be great if you contributed back. So I'd just like to thank the presenters again for coming along. So thank you, Jason and Sheng, for presenting. And I hope you enjoyed that. And hopefully we'll see you on next month's meetup. Thank you, everyone.
Thank you.
Thank you.